This lesson is for geometry, lesson 3.3 on adjacent angles and vertical angles. We're going to start by looking at adjacent angles. Students are probably familiar with the word adjacent. We've used it before in class. Adjacent angles are angles that are next to each other. More specifically, if they have a common side on the interior of the angle formed by the two non-common sides. So here's a typical example of two adjacent angles. We could talk about angle COA and how it's cut into two angles in the middle by ray OB. So now if we look at angle COB right here and angle BOA here, they both share a side, and that side that they share, or that ray that they share, is on the interior of the larger angle. So we would say that angle COB and angle BOA are adjacent to each other. They are adjacent angles. They are right next to each other because they share a ray. So let's try some examples now using that idea or using that definition. So this is example 1 in your textbook. It says, tell why the indicated angles in problems 1 and 2 are not adjacent. So that means they are either not sharing a common side on the interior, or they're not next to each other. So let's look at angle G right here and angle E right there. Clearly they're not next to each other. Adjacent angles would be more like G and D or G and F. So G and E are across from each other. They are not adjacent. G and E also do not share a common side. The sides of angle E are FE and DE. The sides of angle G are GD and GF, so they don't share any common sides. Let's look at number 2. They're saying that angle 7 and angle 8 in this picture are not adjacent. Well, it clearly looks like they share this side YZ. Here's angle 7, here's angle 8. Definitely looks like they're next to each other. However, here's an angle here, and we're not on the interior of that angle. So there's an angle out here, and there's an angle out here, and they are not on the interior of each other. So if we were looking at this, we'd want the adjacent angles to be located somewhere inside this smaller angle. So these are adjacent, but we wouldn't classify them as adjacent using this definition because they're not on the interior of an angle. They're kind of on the exterior of angle XZW. We have a lot of vocabulary today, so let's move on to our next vocab word. An angle bisector. An angle bisector bisects an angle. What that means is it cuts it into two. Anytime you see the prefix bi, it means two. And it has to be, again, on the interior of the angle. And the two pieces that form the bisector, or that the bisector creates, are going to be equal in measure. So if we look at angle PVQ here in this picture, PVQ is cut in half or bisected by ray VR. And you can see that the measure of the smaller angle, or the angle on the left, is 62 degrees, and the angle on the right is 62 degrees. So VR has successfully cut that angle into two equal parts. So we say that the measure of the two angles is equal. So let's do a practice question related to that. Here I've got angle ABD, and ray BC is bisecting it. As soon as you see that word bisector, you know that this angle and that angle will have equal measure. Then they give us some information. They tell us that the measure of angle ABC, ABC is here, is 3x minus 5. So I'm just going to fill that into that angle. They also tell us that angle CBD, so that's this angle here, is negative 2x plus 10, so I'm going to fill that in. Since this bisects the angle, I know that those two angles should be equal. So now I'm going to use my algebra skills and I'm going to set those two angles equal to each other. So I'm simply going to say 3x minus 5, which is one of the angles, should be the same as the other angle, negative 2x plus 10. From here you're going to use your algebra skills. You want to isolate the x's. So your first job is to try to get the x's onto the same side as each other. The easiest way to move the x's is to move the one that's smaller. Between -2 and 3, -2 is a smaller number, so we're going to move -2 and its x over to the other side. Since it's negative, we're going to add the opposite. So I'm going to add 2x to both sides. When I simplify that, I get 5x, the -5 drops, and the 10 drops. Now to isolate the x completely, now that all the x's are together, I'm going to move this 5 by adding 5 to both sides. So over here now I get 15, and then to get rid of a number next to a letter, I divide, because I want 5 divided by 5 to turn that into a 1x. Remember that equations are balanced, so whatever you do on one side, you have to do on the other side. And I ran out of room here, so I'm going to maneuver all the way up over to here. 5x divided by 5 is just going to be x, that's what I was looking for. And over here, 15 divided by 5 is 3. Now I'm not done with this problem. They want me to find the measure of angle ABD, which is the entire angle, the big angle. So I first need to figure out what each angle equals, and then I'm going to double it or add them together to get my total angle. So if x is 3, I'm going to plug that into, let's plug it into this one here. So I'm going to say -2 times 3 plus 10. -2 times 3 is -6, plus 10 is going to be 4. So the measurement of angle CBD is 4 degrees. That means this angle is also going to be 4 degrees. Let's double check it by plugging in 3 for x. 3 times 3 is 9, 9 minus 5 is 4 degrees. So now angle ABD is going to be those two angles together. So that should be 8 degrees altogether. Next up we have the angle measure postulate. If you have adjacent angles, then if you add them together, you'll get the angle measurement for the whole thing. We basically just did that in the problem that we were just looking at. If you're working with two angles that are next to each other and you're trying to find the big angle measure, you can just add them together. So if we were trying to find the measure of angle BVA, we could find it by adding the measure of angle BVC, this angle, and adding it to the measure of the other angle, CVA. So if we knew those individually, we could add them together to get the big angle. And we already used that idea on the previous question. So let's use that idea to do our next example. From the drawing at the right, see if you can figure out the measure of angle DAE. So first let's figure out what angle that is. DAE is going to be that entire angle there. Well, I know that this angle is 35 and this angle is 90, so using this addition assumption, if I add them together, I'll get the entire angle. So I'll simply have to say whatever 90 plus 35 is. Do you know what it is? Yes, 125 degrees. Now let's try the next one. Determine the measure of angle BAE. So let's find where BAE is. So that's this angle here. Let me get rid of those marks from the previous question because those are in my way right now. So as we try to determine that angle, I have this angle up here, I know that angle and that angle. This final angle that I'm trying to find would complete the entire rotation. So if you think about going all the way around the circle, that would be 360 degrees. If I take away the three angles that I know, I'll know what's left. So go ahead and grab a calculator and figure that out. When you're all done subtracting there, you're going to get 131 degrees. So that's this angle here. Now we're not really using angle addition here, we're kind of using that idea backwards. If we add up all the angles all the way around this center point, we'd get 360 degrees. Since we know 3 of them but not the 4th, we just basically work backwards here to try to figure out what's left or what's missing. But it's still the idea of adding them all together to complete our question. 2 more vocab words for you for today: complementary and supplementary angles. Complementary angles add up to 90, supplementary angles add up to 180. And that's just something that students are going to need to memorize. So let's try a practice question. They tell you that ABC and CBD are complementary, and then they give you the measurement of those. So if they're complementary, they should add up to what? Yes, they should add up to 90 degrees. So if you draw a 90-degree angle, cut that angle in half somehow, we can tell from the way that these are worded or labeled that B is going to be down here, because that's the middle of each of my angle names. And then C is in both angles, so that's going to be the common side. So then I know one side is going to have an A, the other side is going to have a D. Students need to be able to figure that out on their own. Whenever they're not given a picture, students should be able to draw their own picture. I know it's going to be complementary because I know it's going to form a 90-degree angle. So then I fill in what I know. Angle ABC is 4x plus 5. Angle CBD is 5x plus 4. Together, I know those two angles are going to make what? 90 degrees. So now if I just use my algebra skills and my angle addition assumption from back here, I can add them together and set them equal to 90, and I'll be able to determine what x is. Here we've got some like terms we can add. 5x and 4x makes 9x, and 4 and 5 makes 9 as well. Now if I solve for x, I would subtract 9 from both sides. And then to determine x by itself, I would simply divide by 9. So we know that x here is going to be 9. So I found the value of x. Now let's determine the measure of angle ABC. ABC is this one here. So now if I substitute in the number that I got for x, I can calculate. So instead of 4x plus 9, I'm going to say 4 times 9 plus 5. And I misspoke there, sorry. 4 times 9 plus 5, not plus 9. So 4 times 9 is 36, plus another 5 is going to be 39. Actually, no, that would be 41. So that was complementary and supplementary. We only did an example of complementary. The only change that you would make if you were working with supplementary angles is that they add up to 180. So they would form a straight line when you put them together. So we're going to do some of that on our next example. Linear pairs, their non-common side is an opposite ray, and they are adjacent to each other. So linear pairs have two characteristics. They're going to be adjacent to each other, which means they share a side, and the other base, or the other part that they share, is opposite rays. So here we have a linear pair. You can see here that if we added up angle 1 and angle 2, they would form a straight line, and we'd end up with 180 degrees. So the linear pair theorem is actually the more important thing for students to look at for today. If two angles do form a linear pair, then they're automatically going to be supplementary. So when you're working with a straight line and an angle or a ray coming out of it, together those two angles should add up to 180, because that's what supplementary means. So when you see a straight line with an angle coming out of it, you should think that those are a linear pair and that they are supplementary. So let's use that idea now to find the measure of angle ABC. So ABC would be this angle here. Since the straight line is formed and there's an angle coming out, I know that together those two angles should be a total of 180 degrees. So if I add the first angle, the x plus 22, if I add it to the other angle, 3x minus 2, I should get 180. So now we're going to just quickly go through this for the algebra to solve for x. X plus 3x is going to be 4x, 22 minus 2 is 20. Now when I solve for x, I subtract 20 from both sides, and then I divide by 4. So x ends up being 40. Now if I plug 40 back in right here, I'll be able to determine just the measure of angle ABC, which is this angle here. 40 plus 22 is going to be 62 degrees. So I'm using the idea of them being a linear pair and supplementary and my algebra skills to find the missing angle. Our last topic for today is vertical angles, and vertical angles are a favorite of mine. Anytime you have two lines that cross each other, there are two pairs of angles that are equal. Angle 1 and angle 3 are going to be equal to each other, and angle 4 and angle 2 are going to be equal to each other. So very similar to our process today, we're going to be using algebra to try to find missing angle measures. So what do we know about this angle and that angle? They are vertical angles, like it says in the question, and they want us to find the measure of angle CAB. So they're asking us for this angle measure here. So we're going to use the idea of linear pair to figure this out as well. So we know that these two angles are going to be equal to each other. So I set them equal, 2x minus 3, and now I'm going to solve that for x. Again, you want to get the x's together. Move the smaller one first. So I'm going to move this x over by adding the opposite of it. So I get x minus 3, and then I add 3 to both sides. So x equals 7. Now I can use that number and plug it back in. So I'm going to plug it back in here. I could have also plugged it in back here. So if x is 7, then I know that this angle measure is 11 degrees. So then that would mean this is also a measurement of 11 degrees. By the way, students, when I draw these figures for you, I do not use a protractor, so you have to imagine that it's 11 degrees. I didn't actually measure it that way. Now, that is not the angle that we're trying to find, however. But if you take a look at this line here, so I'm just going to redraw it, and then this ray coming out here, if I know that this one's 11 degrees, what do I know about this angle? Think back to linear pairs. Linear pairs form a straight line with an angle coming out. Linear pairs are supplementary. So if I know that this angle is 11, I know then that this angle is going to be 180 minus the 11. So when you do that, you get 169. So there we used a lot of our skills from today. We used algebra, we used our definition of vertical angles, and we used linear pair to solve the question. And so students are going to need to get very familiar with linear pair, supplementary, complementary, vertical angles, and adjacent angles.